So this is the Federal Center South building in Seattle. And I'm actually I'm using this project as a setup for the next one. But this was a design build competition where we had to actually guarantee the energy performance of the building. It's on the Duwamish River, and it's actually set on one of the last remaining oxbows on the Duwamish River, and that was an inspiration for the building shape. So the building it's kind of planned as an oxbow around a central commons. And that was actually one of the first questions that we asked, the design team asked the client. So they got a design brief with different departments, and each one had their own conference room. And so one of the questions that ZGF asked them was, what if we created a central commons where you can take all your conference space and move it to the center, and then created a flexible loop around it that you could have open office. So that improves your daylight quality through the entire thing. You're not blocking it with walls. And that was, to the GSA's credit, they went with that idea. So that's the diagram for the building. You have a central commons over there, surrounded by open office around. It's a beautiful, beautiful space. If you're ever in Seattle, highly encourage you to get a tour of it. Part of the competition brief was we had to achieve 30% improvement over ASHRAE 90.1 2007. So there were a whole bunch of high performance goals. I'm going to focus on the 30% energy reduction one, and that was actually, that equated to a 32.3 EUI, but 27.6 with photovoltaics, right? So that was really our target over there. And we worked, it was a design build team with Cellen Construction, ZGF, WSP, Built Ecology as well, and KPFF were our structural engineers. And we did modeling early on, and this was, one of my colleagues developed this method. It's kind of a radiation rose, where you look at energy performance with different directionality. And that kind of allows you to, very early on, kind of optimize where do I want to put most of my glass, how do I want to orient this. And this one looks at, by moving the commons to the center, that actually freed up this floor plate for open day lighting. So you've got a central atrium around it, and then this office floor plate over there. With WSP and Cellen, we developed, actually the chilled sails were something that were developed specifically for this project, and you can see Charles and Jack from Cellen, Charles from WSP over there with the manufacturer talking about that. So a lot of innovation that was driven through this design build process. And then WSP ran some underfloor studies looking at ventilation. So there was analysis through the process, right from up front in terms of orientation through CFD analysis for this. Some really cool technologies that we threw into the project. There was thermal storage, both with phase change materials. And this was a PCM tank that tied into the system. But one of the cool stories here was we actually found out that we needed structural piles for the building. So we were able to route geothermal wells through the structural piles. And as it happens, the groundwater under the building moves a lot. So we actually get more performance out of our piles than we intended, right? Yeah. Yay. So pop quiz, you can't answer it. Which one is using more energy? The one that's on, right? Exactly. So that's really important in terms of how do we, how are buildings actually being operated and controlled? I like to call it weather versus weather, and one of them is climate, right? But the other one, the weather, is understanding how people, whether they operate it as you intended it to. And so this is actually what WSP modeled in terms of occupancy. So, when you go in, you make certain assumptions. You've got to, right? You don't know exactly how they're going to operate the space. What we found with this one, so the orange is what was modeled. You can see it turns down in the evenings and on weekends. The blue is what was actually measured. A little bit of a difference. So really, the computers weren't getting turned off as much as we thought they would. And the peak loads were actually higher than we thought they would. So there are certain adjustments that have to be made for that. The other thing, this was actually one of the guys from Cellen who was doing the controls on the building loaned me this slide. And what this is looking at, so each of these is a zone in the building. These guys over here are perimeter zones. And this thing over here is a Monday after a weekend. And what we found was there was a lot of overheating in the perimeter zones after a weekend. The systems were having a hard time kicking up, so early morning startup was an issue. And this plays not just into energy but also comfort. We were getting a lot of complaints from some of these perimeter spaces. So WSP and Cellen's controls guys went back, tweaked the system. So this is the 4th of July weekend over there. You can see after the tweaks, they went back, adjusted the sequencing of the equipment, performs much better. So it's really, I mean, these are complicated pieces of machinery, and it's really important to understand that feedback is, so it's not just schematic design up front, it's also after you operate it, how do you go back and rationalize this? This was tracking the EUI performance. So these were the allowances, the deductions for plug loads over there, but also for weather, for weather and weather. And that was the adjusted total, and this is in April. But you can see we were still way above what we anticipated. Heating and cooling was a lot more, and pump energy was a lot more. And then Charles did some of his voodoo magic. I'm not sure exactly what he did, but they went back and adjusted stuff, right? So you can see over here, after we got through April, and started to get a better handle on the performance, we're actually, so the dotted line on the top is what we were targeting. The dashed line was what our model said we'd do. So towards the end, we actually started to get in line with the modeled as well. 25.7 was the metered, adjusted for weather and weather in 2013. So better than the target, close to what we modeled. So overall, really, really successful project.